Good evening, everyone. This is Unit 4 of IAL Physics, January 2016. In the first question, a unit of capacitance is a farad. A farad can also be written. So, how we can write farad? Q is equals to CV, or Q divided by V is equals to C. Where Q is the charge is current because we have current is equals to rate of flow of the charge, so I is equals to Q divided by T, so Q is equals to I into T. So in place of Q we can write IT divided by V. The unit of current is ampere, unit of time is second, and unit of voltage is volt, so we'll move this in numerator. So it will be ampere second volt inverse, so that's why E is the right answer. Which graph shows electric field strength due to a negative point charge? So negative point charge, we have the formula E is equals to F divided by Q, where F is the force between the charges, which is given by K Q1 Q2 over R square, and that is divided by Q2. So when we simplify, it will be K Q1 over R square. So it shows a relation between E is inversely proportional into R square, inverse square relation. So if R is double, E will decrease by 4. So inverse relation quantity, so either B will be answer or D. But as they specified, it's a negative point charge. So negative point charge, it will have a negative electric field because it's a vector quantity, and positive. So this one is representing for positive charge, point charge, and this one is representing for negative point charge, and both shows a relation that E is inversely proportional to 1 over R square. That's why D is the right answer. The diagram shows a coin on a horizontal surface which is rotating at a constant angular velocity omega. Which row correctly shows the direction of the frictional force? Direction of the resultant force when object is moving in a circular path is always towards the center. That's why D is the right answer. For question 4, two charges plus Q and minus Q are located as shown. Point diagram where the diagram X is a point halfway between the two charges. Small positive charge moves from plus Q to minus Q. Which statement about the resultant force on this charge as it passes through X is correct? So when we sketch the electric field pattern, the strength of the field depends on the number of the field lines which are passing through that area. So you can clearly see the number of the field lines, the spacing between the field lines is increasing, so it means the strength is decreasing because the spacing between the field lines is showing the strength of electric field. So as the spacing increase, this means the strength of electric field is decreasing. So when we move from plus Q to minus Q, so the strength of electric field or the force will decrease. So the magnitude of the resultant force, it will not be zero because still there are field lines, so it will experience the force, but the strength will decrease. That's why it will be minimum at this point X. The resultant force is not zero. Why? Because there is electric field. The resultant force does not change direction, it remains in the same direction. Magnitude of resultant force is not maximum at X, it is minimum because the field line spacing is more, so the strength decreases, so the force will also decrease. Two parallel plates having a potential of 12 volts across them are separated by 5 exponent minus 4 meter. What is the magnitude of electric field strength halfway? We know electric field strength between the parallel plate is constant, and the formula which relate the strength, voltage and distance V is equals to ED, or E is equals to V divided by D. V is the voltage, which is 12 divided by 5 into 10 to the power minus 4. When we simplify this, it will come out as 24,000 volts per meter inverse, or volts meter inverse, or volts per meter. The Large Hadron Collider is designed to accelerate proton to very high energies in the particle physics experiment. Why very high energies are required? because we use the concept that energy changes into mass, or it is used to create, if more energy is there, it will create heavy particles or massive particles. So it is there to create a large particle or particle with a large mass. An electron has a momentum of 1.9 into 10 power minus 24. The kinetic energy of the electron, for question number 7. So we know kinetic energy is half mv square, but we will relate this with the momentum formula. Ke, the kinetic energy, is equals to half mv square. If you multiply and divide by m, so it will be half m square v square over m equal to Ke, or we can say Ke is equals to 1 by 2m, and m square v square is momentum square, so we can say it is p square. Or we can say Ke multiply by 2 multiply by m in an under root will get. So this is a formula which relates momentum and kinetic, but we need a kinetic energy. So the kinetic energy will be equal to p square over 2m, where p is the momentum, m is the mass of electron, which is 9.11 into 10 to the power minus 31 kg. So you can use a constant, m is there and p is there. So when we substitute the value, it will come out as 2 into 10 to the power minus 18 joule kinetic energy. The particle of mass m and charge q move in a circle perpendicular to magnetic field of flux density b. The graph shows a relation between the radius of orbit r and the velocity. The gradient of this graph is given by, so the basically when it is moving in a circular path, so we say the centripetal force is equals to magnetic force. So centripetal force is equals to magnetic force. Centripetal force is given by mv square over r, and magnetic force is qv b. So this v will cancel with v. So we have formula mv over r is equals to qb. We are plotting a graph between v r on y-axis, so r should be separate. Or if I further simplify, I can say mv is equals to q, b, and r. And r must be separated, so mv over qb is equals to r, or I can say r is equals to m over qb into v. Then I'll compare with the equation of straight line. Y is equals to mx. On y-axis I have r, on x-axis I have b. So my gradient will be m over bq or qb. That's why A is the right answer. Question 9 and 10 refer to a diagram which shows a track of a particle detector. Two particles x and y are created by a decay of lambda particle at O. But we don't see any track of lambda particle. If there is no track of lambda particle, what we conclude? We conclude that it is a neutral particle. That's why there is no track. So C is the right answer. And for question 10, which of the following is correct about momentum? The conservation of momentum, total momentum before should be equal to total momentum after. So the vector sum of momenta of x and y must equal to the lambda particle. That's why C is the right answer. Why the vector sum should not be 0? Because originally the particle was having a momentum, so finally there should be a momentum as well. So this was Unit 4 of IAL Physics, January 2016.